Today we are going to start solving exponential and logarithmic equations. We're going to do this over 2 days. So the first few problems that we're going to work are going to be exponential equations. So you can express your solution in terms of any logarithm. We are going to choose to do the natural logarithm, okay, the ln, because we have a natural log button on our calculator. Okay, another common one is to write it in terms of the common log, so log base 10, again, because we have that on our calculator. And then we want to round our answer to the nearest hundredth, and so just remember that hundredth means 2 decimal places. Okay, so whenever we are solving exponential equations, our goal is to get the exponential expression by itself on one side of the equation. So you'll notice here, 4 to the x is by itself on the left. That is an exponential expression, and we have a constant 243 on the right. So the way that we are going to start to solve this equation is we are going to take the natural log of both sides. So we're going to do the natural log of 4 to the x is going to equal the natural log of 243. Excuse me. Okay, this is the same as any equations we ever did before. As long as we do the same thing on both sides of the equations, we're still going to have equality. Okay, so since we took the natural log of both sides, these expressions are still equal to each other. Next, we are going to use the properties of logarithm, the power property, to rewrite this expression. Okay, since x is in our exponent, we are going to move that out front. And the left side simplifies to x ln of 4. Our right side is still natural log of 243. So we need to remember, and I think people often forget, the natural log of 4 is a number. The natural log of 243 is a number. So the natural log of 4 is, even though we're writing x first, is almost like our coefficient, our constant that is in front of x. So to get x by itself, we can divide both sides by the natural log of 4. So the natural log of 4 is going to divide out on this side. We're going to get x equals the natural log of 243 divided by the natural log of 4. Okay, this is my exact answer. So, on a quiz or a test, when I am asking you for an exact answer, this is an exact number. This is an exact answer. Okay, it's exactly the number that I need to plug in up here in order to get it to be true. But what we're going to do next is we're going to find an approximate. Okay, so you're going to need a calculator for this. Thank God we don't have to use those log tables that I showed you the other day. So we are going to grab our calculators and we are going to type in the natural log. Again, I'm sort of anal about this. I'm going to type in the natural log of 243. I'm making sure I have my argument in parentheses. I'm making sure I have my numerator in parentheses, divided by the natural log of 4. Okay, and so I get that is about 3.9. I want to round to 2 decimal places, so 3.96. Okay, so on our quiz or test, we can check this. So let's do a check. So we want to see if 4 raised to the 3.96 is about 243. Okay, again, I'm using the approximate symbol because I'm using a rounded estimate. So I come back to my calculator and I am trying 4 raised to the 3.96. and I get 242.19, which is very close to 243. So I can feel pretty confident that I have the correct answer. For our next one, letter B. Again, we want to get our exponential expression by itself. Right now, this is not by itself. Okay, so I am going to subtract 5 from both sides. On the left, I'm going to be left with 3 e to the x equals 83 minus 5 is 78. I'm going to divide both sides by 3. So I'm going to have e to the x is equal to 26. So now I have my exponential expression, and it is isolated on one side of the equation. So now I am going to take the natural log of both sides. Again, you can take any log base, okay, but we're picking between natural log and common log, okay, base e or base 10, because we have those buttons in our calculator. Also, this one especially we would have picked base e because the natural log of e to the x is just going to be x. So x is going to be equal to the ln of 26, the natural log of 26. So again, this is my exact answer. And if I want to find my rounded answer, I use my calculator. The natural log of 26 is going to be about 3.26. Okay, and again, if we want to check this, okay, I'm seeing if 3 times e to the 3.26 plus 5, if that is about 83. So 3 times e to the 3.26 plus 5, very close to 83, so my answer checked. Okay, let's move on to letter C. So again, we want to get our exponential expression by itself. We are going to divide both sides by 8. So I get 3 to the 6 minus x equals 5. Now that I have my exponential expression isolated, I'm going to take the natural log of both sides. And next, again, I want to this isn't fully simplified because I have an exponent on my argument. So I am using my exponent moving my exponent to the front. So now my ln of 3 is just a number, it's a constant. So I'm dividing both sides by ln of 3, natural log of 3. And I get 6 minus x is equal to the natural log of 5 over the natural log of 3. I'm going to move up here a little bit. So I am going to move x to the other side, so I'm adding x to both sides, and I have x equals 6. I am subtracting ln of 5 over ln of 3 from both sides. And this, again, is my exact answer. So again, I want to see what that is as a decimal. Sorry, I know the glare is tough on this. So I am doing 6 minus the natural log of 5 divided by the natural log of 3, and I get that x is approximately 4.54. Okay, and when I check this, I'm going to use my calculator. I'm going to save myself the time of writing it over. So I'm going to see if 8 times 3 to the 6 minus 4.54, that's about 40. Okay, so this checks in my calculator. Okay, I am hoping to get through D before my 15-minute time runs out here. So this problem is a little different, right? Because we have exponential expressions already by themselves on both sides of the equation. So we are going to take the natural log of both sides. Then we are going to use the power rule for logarithms. Your parentheses are important. X plus 4 times the natural log of 3 is going to be equal to 1 minus 3x times the natural log of 2. So again, the natural log of 3 is just a number, so I'm going to use the distributive property. Okay, because my goal is to get x by itself, so I have to do some algebraic manipulating. Sorry about that. So this simplifies to ln of 3 x plus 4 natural log of 3 equals the natural log of 2, so I'm just distributing natural log of 2 times 1, minus 3x times the natural log of 2. So now we want to group variables and we want to group constants. So I am going to move this, because it has an x over here, so I'm going to have, and I'm going to rewrite this, x natural log of 3, so that's my first term. I am moving over this, so it's becoming a positive 3x natural log of 2, and that's going to be equal to the natural log of 2, that's staying right here, and I am moving over minus 4 ln natural log of 3. So notice I have all my x terms grouped on one side, my constant terms grouped on the other side. So this is a trick that you need to learn. You need to factor out an x. So this becomes natural log of 3 plus 3 natural log of 2. And that's going to be equal to the natural log of 2 minus 4 times the natural log of 3. Next, we are going to divide by ln of 3 plus 3 ln of 2 on both sides. And this is my exact answer because these factors cross out. Remember, you cannot divide out, you cannot cancel if there's addition or subtraction. So this ln natural log of